Hello there, my friend. Welcome back to another peaceful journey through the cosmos. I'm so glad you're here with me tonight, settling in for something truly extraordinary. There's something magical I want to share with you. Something that'll change the way you see every pebble, every mountain, every grain of sand. It's this beautiful truth that rocks, yes, ordinary rocks, they remember everything. They're Earth's perfect historians, recording every moment, every change, every whisper of time in their crystal hearts. Tonight, we're going to discover how a simple stone can tell you about rainfall from 1,000,000 years ago. How some crystals have been growing atom by atom since before the dinosaurs. How scientists can read the story of Earth's entire history just by looking at the layers and patterns locked inside these silent witnesses. And you know what? If you're finding some comfort in these words already, if this idea of eternal memory speaks to something deep within you, I'd be so grateful if you gently tap that like button. It really helps these stories reach more dreamers like you. And maybe if you'd like more of these cosmic journeys, you could subscribe, become part of our little constellation of peaceful souls. I always love reading your thoughts in the comments too, hearing what wonders help you drift off to sleep. But there's no pressure at all. We're just here together, you and I, sharing this quiet moment beneath the stars. So let's get comfortable now. Let yourself sink a little deeper into wherever you're resting. Feel the weight of your body, solid and present, just like the rocks we're about to become. Let your breathing slow down, matching the patient rhythm of geology itself. Billions of years compressed into each gentle breath, in and out. You're safe here, held by the same gravity that's been pulling atoms together since Earth began. Your bed, your pillow, they're made of atoms that have existed since the birth of stars, minerals that have been cycling through this planet for eons. You're already part of this ancient story, already connected to the deep memory of Earth. Tonight, you're going to experience something remarkable. You're going to become an iron atom. Yes, a single atom of iron. One that's existed since before Earth was even born. You'll feel what it's like to be created in the heart of a dying star, to drift through space for millions of years, to finally find your way to this young planet. And then the real journey begins. You'll sink into Earth's molten core, rise slowly through the mantle, crystallize into your first mineral. And every time you become part of a rock, you'll record everything around you. The temperature, the pressure, the chemistry of that exact moment, frozen in stone forever. This isn't just imagination. This is real science wrapped in wonder. Every rock you've ever held contains iron atoms just like you'll be tonight. Atoms that really have traveled this exact journey, from stellar nurseries to your hand. And they really do remember. In their crystal structure, in their chemical bonds, in the way they've arranged themselves. They hold the memory of every environment they've been part of. Scientists can look at a piece of granite and tell you how deep underground it formed. They can examine a layer of clay and pinpoint the exact year an asteroid struck Earth. They can study the rings in a stalactite and map out centuries of rainfall. You're about to understand rocks in a way that'll make every stone shimmer with story. every mountain glow with memory. You'll discover why some crystals deep in caves have been growing continuously for millions of years, adding one atom at a time, like the universe's slowest, most patient clock. You'll learn how the rocks in your garden might contain evidence of ancient oceans, volcanic eruptions, ice ages, all of it recorded, all of it remembered, waiting for someone who knows how to read their silent language. So as we begin this journey, as you prepare to become this ancient iron atom, just let yourself drift. There's nowhere else you need to be, nothing else you need to think about. You're about to experience 4.5 billion years of Earth's history. But time moves differently in the world of rocks. What took eons will pass like gentle waves tonight, washing over you, carrying you deeper into rest with each transformation, each crystallization, each patient moment of geological time. Let's go back, way, way back, before Earth, before the sun, before anything you'd recognize as home. You're floating in the heart of a massive star. Not our sun, but an ancient giant that lived and died billions of years ago. You're not iron yet, just simpler elements being squeezed together in unimaginable heat. It's not violent though. It's more like a cosmic lullaby. Atoms dancing together, fusing, transforming, creating heavier and heavier elements in a slow, stellar ballet. For millions of years, this star has been your womb, keeping you warm, building you up atom by atom. And you know what's beautiful? Iron is special. It's the most stable element, the one that stars can't fuse any further without losing energy. So when you finally become iron, when those final protons and neutrons settle into place, you're perfect, complete. The star's final masterpiece. You'll carry this stability with you forever. Through every rock you'll ever become part of, every crystal you'll help form. Then one day, though day doesn't really mean anything here, the star begins its final transformation. It's not scary, it's magnificent, like the universe's gentlest firework. The star swells, glows brighter, and then releases you into space, along with trillions of your iron siblings, all drifting outward in a slowly expanding cloud of stardust. You're free now, floating through the darkness, carried on stellar winds that move like whispers between galaxies. For millions of years, you drift and drift and drift. Sometimes you pass near other stars, feeling their distant warmth. Sometimes you float through absolutely nothing, just you and the infinite quiet of space. But you're never really alone. All around you are other atoms. Carbon, oxygen, silicon, all born in stars, all drifting together like a vast, slow river of possibility. And gradually, so gradually you don't even notice it happening, gravity begins to pull you all together. It starts as the gentlest tug, barely noticeable. But over millions more years, you and billions of other atoms begin swirling, clustering, forming a massive cloud that's slowly, slowly spinning. This is the solar nebula, the birthplace of our sun and all the planets, including the one that'll become your home. You're part of something so much bigger now, a cosmic recycling project where old star stuff becomes new worlds. The cloud keeps spinning, keeps contracting, and in the center, our young sun ignites. Its light pushes through the dust and gas, warming you for the first time in eons. But you're not destined for the sun. No, gravity has other plans for you. You're caught in a smaller whirlpool, one of many swirling around the new star. This one's special, though. It's in just the right place. Not too close to the sun, not too far. The perfect spot for something wonderful to happen. More and more material gathers in your whirlpool. Dust grains stick together. Pebbles collide and merge. Boulders crash gently into each other and hold on. You're inside one of these early fragments, watching, feeling, as the baby Earth grows grain by grain, collision by collision. It's like the universe is building a home just for you, just for all the atoms that'll make this planet special. The process is hypnotically slow, each impact adding just a little more mass, a little more gravity, pulling in more material, which creates more gravity, which pulls in even more. It's a peaceful accumulation, like snow gathering on a winter night. Except the snow is cosmic dust, and the night lasts millions of years. You can feel the proto-Earth growing around you, getting warmer as gravity squeezes everything tighter, transforming from a cold cluster of debris into something more, something with its own presence, its own pull. And now, now things get interesting. The Earth is big enough that the impacts generate real heat. Each collision releases energy, warming the young planet from within. You're no longer on a cold rock in space. You're part of something that's beginning to melt, to flow, to come alive in its own geological way. The surface is still being bombarded by asteroids and comets, each one adding more material, more heat. It's like the universe is kneading the Earth, working it, shaping it, preparing it for everything that'll come. The heat keeps building. Radioactive elements deep inside decay, releasing more warmth. Gravity continues squeezing everything inward, and then something remarkable happens. The Earth begins to differentiate. The heavier elements, including you, my iron friend. You begin to sink. Not quickly. Nothing happens quickly in geology, but steadily, inevitably. You're pulled down through the molten rock, deeper, deeper, heading for the very heart of the planet. This is your first transformation on Earth, from cold cosmic dust to molten iron, sinking through magma that glows orange and red. It's not frightening. It's like settling into the warmest, deepest bath, where pressure and heat embrace you from all sides. You're joining the core now, the iron heart of Earth, where you'll spend your first few 100 million years, just being, just existing in that perfect molten state, recording the birth of a planet in your very atoms, down here in the core. It's different than anywhere else you'll ever be. The pressure is so intense that iron behaves in ways it never could on the surface. It's liquid in the outer core where you are now, flowing in massive currents that generate Earth's magnetic field. That's right. You're part of the planet's magnetic shield, protecting all future life from solar radiation. You're essential. Even now, at the very beginning. The temperature is about 10,000 degrees Fahrenheit, as hot as the surface of the sun. But it doesn't feel chaotic. It feels like being part of a vast, slow dance. Iron currents flowing in majestic patterns, driven by Earth's rotation and heat from below. You flow with them, around and around, up and down. A metallic ocean hidden beneath miles of rock. Sometimes you drift near the boundary with the inner core, where pressure squeezes iron into solid crystal despite the incredible heat. You can feel the difference, the change in how atoms move or don't move. It's like approaching a sleeping giant made entirely of iron, perfectly still, perfectly ordered, recording conditions that have existed since Earth was young. You spend millions of years here, just flowing, just being part of Earth's deep heartbeat. But even in the core, things change. Slowly, incredibly slowly, the planet is cooling. What was completely molten begins to develop layers. The mantle above starts to become more solid, more structured. And you, patient iron atom that you are, you begin the longest elevator ride in the universe, starting your journey upward. It begins with a plume of extra hot material, a slowly rising bubble of heat that catches you in its flow. You're leaving the core, entering the lower mantle. It's still mostly liquid here, but different. The pressure is less crushing, the temperature a bit cooler, though still thousands of degrees. You're made of different minerals now, combined with oxygen and silicon into dense compounds that can only exist under these extreme conditions. The journey upward takes millions of years, and you feel every moment of it, not as waiting, but as transformation. Each mile you rise through the mantle, the conditions change just a little. The pressure eases, like a gentle hand slowly releasing its grip. The temperature drops degree by degree, and with each change, you become part of different minerals, olivine, pyroxene, each one a new way of being, a new arrangement of atoms that perfectly matches the conditions around you. You're in a convection current now, one of Earth's great circular rivers of rock. It's solid rock, but it moves like the slowest honey, flowing upward where it's hot, cooling and sinking where it meets the colder upper regions, then heating and rising again. The cycle takes millions of years to complete, but you have nothing but time. You're recording everything, the exact pressure, the exact temperature, the chemical soup of elements around you, all of it locked into whatever mineral you've become. Sometimes you pause in your journey, getting stuck in a particularly stable layer, spending a few million years just existing at that depth. And that's when something magical happens. You start to grow. Other atoms of iron, silicon, oxygen, they find you and attach themselves in perfect patterns, building crystals atom by atom, layer by layer. It's like the universe is knitting with minerals, creating these perfect geometric structures that record the exact conditions of their birth. You can feel the other minerals around you doing the same thing. Garnets forming under the highest pressures. Their atoms squeezed into tight, dense arrangements. Feldspars crystallizing where it's a bit cooler. Their structure more open, more relaxed. Each mineral is like a thermometer and pressure gauge combined, freezing a moment of Earth's deep history into stone. And you're part of this recording, this remembering, your position in the crystal lattice determined by conditions that might never exist in exactly the same way again. The mantle isn't uniform. Oh no. It's full of variations, hotspots where plumes rise from near the core, cooler regions where old ocean floor has been pushed down and recycled. You pass through all of these environments on your slow rise. Sometimes you're part of a mantle plume, superheated and rising faster than usual. Well, faster in geological terms, maybe an inch per year instead of an inch per decade. These plumes will eventually become volcanoes. But that's still millions of years away for you. Other times you get caught in a subduction zone, where you're actually moving sideways or even downward for a while, mixing with minerals that formed near the surface and got dragged down. They carry different memories, different chemistries, traces of water and carbon from the world above. You exchange atoms with them, creating new minerals that could only form where the surface world meets the deep earth. Recording these meetings in crystal structures that scientists will one day read like books. As you rise higher, approaching the upper mantle, things become more dynamic. The rocks here have more water locked in their crystals, just tiny amounts, but it changes everything. Makes them flow more easily, melt at lower temperatures. You become part of these hydrous minerals, amphiboles with their chain-like structures, micas that split into perfect sheets, each structure telling the story of water's journey into Earth's interior. You're getting closer to the surface now, only 60 miles below, which sounds like a lot. But after your journey from the core, it feels like you're almost there. The pressure is still intense, the heat still tremendous, but you can sense change coming. The rocks around you are more restless, more likely to melt, to rise quickly in volcanic eruptions. You've spent so many millions of years in solid minerals that the thought of becoming liquid magma again feels almost exciting. And then it happens. The rocks around you begin to melt, not all at once. Minerals melt at different temperatures, so it's a gradual process. The feldspar goes first, then the pyroxene, creating pockets of magma between still solid crystals. You're in one of these pockets, liquid for the first time since you left the core. But this isn't the same kind of liquid. This is magma, full of dissolved gases, complex chemistry, the stuff that builds new land. The magma is less dense than the solid rock around it, so it rises, squeezing through cracks, pooling in chambers, gathering more melt as it goes. You're part of a magma chamber now, just a few miles below the surface. It's like an underground lake of liquid rock, slowly churning, slowly cooling. Minerals beginning to crystallize out of the melt in a specific order. The ones that freeze at the highest temperatures first. This is where your story really begins to get interesting, because you're about to become part of your first real rock. Not just mantle material, but an actual rock that might one day reach the surface. You can feel yourself cooling, the atoms around you slowing down, organizing themselves. And then, oh, this is beautiful. You crystallize. You become part of an olivine crystal, one of the first minerals to form from the cooling magma. The process is mesmerizing. Atoms of iron, magnesium, silicon, and oxygen arranging themselves in perfect patterns, building a crystal lattice that's both strong and beautiful. You settle into your position, locked in place by the bonds around you. And in that moment, you record everything. The exact temperature of crystallization, about 2,000 degrees Fahrenheit. The pressure, still high, but nothing like the deep mantle. The chemistry of the magma, rich in iron and magnesium. Around you, other crystals are forming. Pyroxenes with their chain structures. Plagioclase feldspar with its complex framework. Each one crystallizing at a slightly different temperature. creating a rock that's like a three-dimensional recording of the cooling process. Early crystals trapped inside later ones, showing the exact sequence of events, the cooling history written in stone. You're part of a gabbro now, a dark, coarse-grained rock that formed slowly underground. The slow cooling is important. It gives atoms time to find their perfect positions, to build large, well-formed crystals. Each crystal is like a page in Earth's diary, and you're part of the ink. Every mineral records the conditions when it formed, creating a rock that's really a library of information about Earth's interior. But your chamber isn't isolated. It's connected to the surface by a network of cracks and conduits. And periodically, the magma finds a way up. Maybe it's triggered by new melt arriving from below, or by gases building up pressure, or by the slow stretching of the crust creating pathways. Whatever the cause, you suddenly find yourself moving upward, fast by geological standards, rising through the crust in a volcanic eruption. The journey to the surface is intense. The pressure drops rapidly. Dissolved gases come out of solution, creating bubbles that drive the eruption. The magma around you cools quickly as it rises, but you're already crystallized, already locked in your olivine structure. So you ride along as a solid crystal in the flowing magma, recording this journey not in your structure, which is already set, but in tiny cracks and imperfections caused by the rapid changes. And then, after 4.5 billion years, you reach the surface. The magma erupts from a volcanic vent, flowing as lava across the landscape. You're in this lava, still in your olivine crystal, but now exposed to air for the first time. The surface of the lava cools almost instantly, forming a glassy crust, while underneath, the flow continues, carrying you along. When the lava finally stops and cools completely, you're part of a basalt, a fine-grained volcanic rock. Your olivine crystal is surrounded by a matrix of tiny minerals that cooled too quickly to form large crystals. It's like being a time capsule within a time capsule. Your crystal recording the slow cooling underground, the surrounding rock recording the rapid cooling at the surface. Together, you tell the complete story of a volcanic eruption. Now you're at the surface, exposed to something entirely new: weathering. Rain falls on your basalt, the first rain you've ever felt, and it's slightly acidic, carrying carbon dioxide from the atmosphere. The water seeps into tiny cracks, freezes and expands, thaws and contracts, slowly, patiently, breaking your rock apart. It's not destruction, though. It's transformation. You're being prepared for your next journey, your next way of remembering. The olivine crystal you're part of doesn't last long at the surface. Well, long in human terms. A few thousand years, maybe. Olivine is one of the first minerals to weather, to break down, to transform into something new. The iron in your crystal reacts with oxygen, creating rust, iron oxides that stain the rock reddish-brown. You're still recording, still remembering, now capturing the amount of oxygen in Earth's early atmosphere, the chemistry of ancient rain. Gradually, grain by grain, your basalt crumbles. Your iron atom, once locked in olivine, is now part of a tiny clay particle, washed by rain into streams, carried toward the sea. This is how rocks remember the movement of water. Every mineral that dissolves, every particle that's transported. It all records the flow patterns, the climate, the shape of the land billions of years ago. You tumble along riverbeds, sometimes moving, sometimes resting for centuries in a quiet bend. Each time you stop, you might get buried by other sediments, becoming part of a layer that records that moment. A flood, a dry season, a normal year. Scientists will one day read these layers like tree rings, each one a memory of conditions when it formed. Finally, after thousands of years of traveling, you reach the ocean, Earth's early ocean, so different from today. The water is full of dissolved iron. There's barely any oxygen. The chemistry is completely alien, but you settle into this strange sea, drifting down through the water column, finally coming to rest on the seafloor, becoming part of the sediment, the slowly accumulating blanket of particles that's constantly recording ocean conditions. You're in a special time, about 2 billion years ago, when something revolutionary is happening. The first photosynthetic bacteria are beginning to pump oxygen into the water, just tiny amounts at first, but it's enough to trigger a reaction. The dissolved iron in the seawater combines with this new oxygen, creating iron oxides that precipitate out, settling to the seafloor in rusty layers. You're part of these layers, these banded iron formations, alternating bands of iron-rich and iron-poor sediments. They're like a barcode, recording the pulsing rhythm of early oxygen production. When oxygen levels rose, iron precipitated. When they fell, regular sediments accumulated. Back and forth for millions of years, creating these striped rocks that perfectly preserve Earth's transition to an oxygen atmosphere. Layer by layer, you're buried deeper. The weight of sediments above slowly compresses everything, squeezing out water, pressing particles together. You're becoming part of a sedimentary rock now, your iron oxide grain cementing together with countless others. And at this rock, you're recording so much. The chemistry of ancient seas, the first breath of oxygen, the rhythm of early life, sometimes mixed in with the regular sediments. There are special additions. A volcanic eruption on a distant island sends ash drifting across the ocean, settling as a distinct layer. A massive storm tears up the seafloor, creating a jumbled layer of mixed sediments. Each event leaves its signature, its memory, preserved in the slowly accumulating stack of seafloor sediments. And then there's life. Oh, the memories of life you're accumulating. Tiny shells of microscopic organisms rain down constantly, made of calcium carbonate, recording the temperature and chemistry of the water they lived in. When they're buried with you, they become part of the rock, their shapes preserved, their chemistry intact. Tiny thermometers from ancient oceans. You spend 100 million years on that ancient seafloor, buried under mile after mile of sediments, compressed into solid rock. The pressure and heat are starting to change things. Not enough to melt anything, but enough to start reorganizing minerals, dissolving some, growing others. You're becoming part of new minerals now, maybe magnetite or hematite, iron minerals that form under specific conditions, recording the temperature and pressure of deep burial. The seafloor you're part of isn't static. It's moving, carried on massive tectonic plates that creep across Earth's surface at the speed your fingernails grow. You're heading for a collision. The seafloor approaching a continent, and when they meet, everything changes. The seafloor starts sliding under the continental edge, pulling you down at an angle, back into Earth's interior, but also squeezing you, deforming you, preparing you for your next transformation. The pressure builds gradually at first, then more intensely. You're in a subduction zone now, where ocean crust dives beneath continental crust. It's one of Earth's great recycling systems, but it's also where mountains are born. The rocks around you are being squeezed like putty, folded, fractured, metamorphosed into entirely new forms. You feel the change happening, atoms rearranging, minerals transforming. What was sedimentary rock is becoming metamorphic. The clay minerals break down, reforming as micas that shimmer with perfect cleavage planes. The iron oxides concentrate into bands, creating patterns that record the direction and intensity of pressure. Every mineral that forms is perfectly suited to these new conditions and perfectly records them. The rocks above you are crumpling like paper, folding into massive mountain ranges. You're deep beneath these growing mountains, maybe 10 miles down, where the pressure is so intense that solid rocks flow like taffy. But it's slow, so incredibly slow. The mountains above are rising maybe a fraction of an inch per year, and you're part of their foundation, part of their deep roots. You're in a garnet now, a beautiful crystal that only forms under high pressure. Your iron gives it a deep red color, like crystallized blood of the earth. The garnet grows slowly, zone by zone, each layer recording slightly different conditions as the mountains evolve. It's like tree rings, but in 3 dimensions, a sphere of memory growing atom by atom. Around you, other metamorphic minerals are forming, each one specific to certain temperatures and pressures. Staurolite crystals that look like fairy crosses, only forming in a narrow range of conditions. Kyanite with its bladed blue crystals, stable only at high pressure. Each mineral assemblage is like a pressure-temperature gauge, frozen in stone, telling geologists exactly how deep these rocks were buried, how hot they got. The mountain building continues for millions of years, continents colliding in slow motion, pushing these ranges higher and higher. The Himalayas, the Alps, the Rockies, all built this way. And deep in their roots, minerals like your garnet are recording every stage, every pulse of pressure, every degree of heating. It's all there in the crystals, waiting to be read. But mountains don't last forever. Even as they're being pushed up from below, they're being worn down from above. Erosion is constantly working. Rain and ice breaking down the peaks, carrying them grain by grain toward the sea. The deep rocks you're part of, they're slowly approaching the surface as the mountains above are stripped away. It takes tens of millions of years, but eventually, erosion cuts deep enough to expose your metamorphic rocks. Your garnet crystal, formed miles underground, now sits at the surface, recording a journey that spanned vertical miles and horizontal centuries. And the cycle is ready to begin again. Weathering will break you down. Rivers will carry you away. You'll become sediment once more. But before your garnet weathers away completely, something else happens. Rain seeps into cracks in the rock. Not just any rain, but water that's picked up carbon dioxide from the soil, making it slightly acidic. This weak acid slowly, ever so slowly, dissolves some of the minerals around you. Not your garnet. Garnets are tough, but the calcite and other carbonate minerals nearby, they dissolve, leaving spaces, channels, the beginning of caves. You watch this process for thousands of years, water trickling through cracks, dissolving rock, carrying it away in solution. The passages grow wider, connect with others, forming networks of tunnels and chambers. And sometimes, just sometimes, you break free from your garnet crystal, released as a single iron atom into the flowing water, carried deeper into these growing caves. The cave water is special. It's saturated with dissolved minerals, carrying the memory of every rock it's passed through. And when conditions are just right, when the water enters a cave chamber where it can evaporate slightly or release some carbon dioxide, those minerals precipitate out. They don't just fall, though. They crystallize, slowly, methodically, building something beautiful. You become part of a stalactite, incorporated into the calcite crystal structure as an impurity that adds color, a faint rust stain in the otherwise white mineral. But you're not just decoration. You're a timekeeper. Each layer of the stalactite, each ring of growth, records the rainfall above. Thick layers mean wet years. Thin layers mean drought. The chemistry of each layer records the temperature, the vegetation above, even the season. Growing a stalactite is perhaps the slowest process you've experienced yet. And you've experienced some slow processes. Each drop of water, hanging from the cave ceiling for minutes or hours, deposits an invisibly thin layer of calcite. It might take 100 years to grow an inch, 1,000 years for a foot. Some stalactites have been growing continuously for millions of years, patient monuments to the persistence of dripping water. You're deep in the crystal structure now, watching new layers form around you. It's hypnotic. Drip, crystallize. Drip, crystallize. Each drop is slightly different, recording the exact conditions when it fell. Was it a summer rain that percolated quickly through warm soil? That leaves one signature. Was it snowmelt seeping slowly through frozen ground? That's completely different. It's all preserved, all remembered in the crystal lattice. The cave is alive with growth, not just your stalactite, but stalagmites rising from the floor, flowstones coating the walls, delicate soda straws hanging like frozen rain, each formation recording different aspects of the environment. The flowstones remember flood events. The soda straws record the steadiest seepage. Together, they create a library of climate history, written in stone. Sometimes the conditions change dramatically. An earthquake shifts the water flow. Your stalactite stops growing, dried out, abandoned. But the pause itself is recorded, a boundary in the crystal where growth stopped and later resumed. Maybe centuries later when water found its way back. These interruptions are memories too, recording tectonic events, climate shifts, changes in the landscape above. In other parts of the cave, different minerals are forming, crystals that could never exist at the surface. Some caves have gypsum flowers, delicate crystals that curl and twist like frozen smoke. Others have cave pearls, spherical concretions formed by water dripping into pools. rotating grains until they're perfectly round. Each type forms under specific conditions, remembering the exact environment of its birth. There's one cave in Mexico, the Cave of Crystals, where gypsum crystals have grown to the size of tree trunks. Some are 30 feet long, weighing tons. They've been growing for 500,000 years in water just below the temperature where gypsum dissolves. Degree by degree, atom by atom, the largest crystals on Earth, recording 500,000 years of perfectly stable conditions. Your stalactite isn't quite that spectacular, but it's still a marvel of patience and precision, and embedded in its layers are other memories, pollen grains that washed in from above, preserving a record of ancient forests, traces of volcanic ash from distant eruptions, marking specific moments in time. Even the cosmic rays that occasionally alter atoms in the crystal, creating isotopes that scientists can use as clocks. The cave system keeps evolving. Lower passages flood and drain with change in water tables. Upper chambers dry out as rivers cut deeper valleys. Your stalactite witnesses it all, sometimes growing, sometimes pausing, always recording. It's like being inside Earth's most accurate rain gauge, one that's been operating for hundreds of thousands of years. And then, after growing peacefully for millennia, something extraordinary gets recorded. A layer unlike any before, rich in unusual elements, iridium, platinum, shocked quartz crystals that speak of incredible pressure. This layer is special. It's recording something that happened 66 million years ago. Though your stalactite is forming much later, the groundwater is carrying sediments from that ancient event, the day everything changed. You see, above your cave, exposed at the surface, there's a layer of rock that exists all around the world. A thin band of clay that marks one of Earth's greatest catastrophes and transformations. The water seeping through this layer carries its signature, its memory, and deposits traces of it in your stalactite. You're about to become part of a much bigger story, a memory that spans the entire planet. Let's follow that story to its source. The iron atom that is you, released from the stalactite by slightly more acidic water, carried up through the cave system by a flooding event, deposited finally in a layer of mud that contains countless other iron atoms, all of them having arrived here through different journeys, but all of them about to witness something unprecedented. You're on the Yucatan Peninsula, though it won't be called that for millions of years. It's the end of the Cretaceous period. The world is warm, tropical. Dinosaurs still rule the land. The giant marine reptiles patrol the seas. It's been this way for over 100 million years, so long that it seems like it'll last forever. But you're about to record the day it ends. The first sign is a brightness in the sky, getting larger, larger. A piece of space, a rock 6 miles across, is approaching at 40,000 miles per hour. It's carrying the energy of billions of atomic bombs, about to be released all at once. You're in seafloor sediments not far from where it'll hit, perfectly positioned to record everything. The impact is, there are no words really. The asteroid vaporizes instantly, along with thousands of cubic miles of rock. The seafloor where you are liquefies, then vaporizes, then condenses, all in seconds. You're launched into the atmosphere in a cloud of molten rock, experiencing temperatures hotter than you felt since you were inside a star. But you don't melt. You can't. You're just an atom. Instead, you become part of the glass spheres that form as the vaporized rock cools. These glass spheres, they rain down across the entire planet, a layer of them, billions upon billions, each one a frozen droplet of that terrible moment. You're in one of them, recording the chemistry of the impact, the mix of asteroid and Earth rock, the temperature of formation, the speed of cooling. Every sphere is a tiny black box, preserving data from the worst day in Earth's history. But that's just the beginning of what gets recorded. As you settle back to Earth, now hundreds of miles from the impact site, you land in a shallow sea. The water is full of debris. The sky is dark with ash and soot from global wildfires. The darkness will last for months. Photosynthesis will stop. The food chains will collapse. And all of it, every detail, is being recorded in the sediments accumulating around you. The layer forming now is unlike anything in Earth's history. It starts with the glass spheres like the one you're in. Then comes the ash from the fires. Then the fine dust that stayed airborne for weeks. And finally, most telling of all, a clay layer rich in iridium, an element rare on Earth but common in asteroids. This iridium-rich clay exists everywhere on Earth, the same age everywhere, a planetary bookmark marking the end of one era and the beginning of another. You're part of this boundary clay now, mixed with countless other particles. It's only an inch or two thick, but it records the complete collapse and restart of Earth's biosphere. Below it, fossils of dinosaurs, ammonites, countless species. Above it, almost nothing at first. Then slowly, new forms, tiny mammals beginning to diversify, new types of plants, a different world entirely. Scientists will one day find this layer everywhere, in sea cliffs in Denmark, in riverbeds in Montana, in deep ocean cores. Always the same signature, always the same age, 66 million years ago. It's Earth's most perfect example of how rocks remember catastrophe, how a single moment can be preserved in stone forever, and you're part of it. One atom among trillions, but each one a witness, each one holding the memory. The world that reforms after the impact is so different. You're buried now beneath newer sediments. But these sediments tell a story of recovery, of evolution trying new experiments. The climate swings wildly at first. Hot periods when palm trees grow at the poles, then cooling, then warming again. Each swing recorded in the minerals forming in the sediments above you, in the types of shells, the chemistry of the water. Time passes, millions of years condensing into layers of rock, and you begin another journey. The tectonic plates are moving again, shifting, rearranging the continents. The seafloor you're buried in is being pushed upward, lifted above sea level, becoming dry land. Your impact layer, that thin band of memory, is now exposed in cliff faces, in road cuts, waiting for someone to read its story. But we're not done with your journey. Not nearly. Erosion finds you again, breaking apart the sedimentary rocks, releasing you back into the cycle. This time you're carried by rivers toward a new ocean. But the world is changing again, growing colder. Ice is beginning to accumulate at the poles. Glaciers are starting their slow advance. You end up in a lake bed in what will become Canada, settling into the mud just as the climate tips into something profound. An ice age. Not the first Earth has seen, but this one is special. It comes in waves, glacials and interglacials, cold and slightly less cold, and you're about to record all of it in the most patient way possible. The first ice arrives slowly, snow that doesn't fully melt in summer, accumulating year after year, compressing into glacial ice. The ice sheet grows, spreads, eventually covering your lake with a blanket 2 miles thick. The weight is incredible, pressing down on the land, actually depressing Earth's crust into the mantle. And beneath it all, you're being squeezed into the bedrock, recording the pressure of ice that reaches toward the sky. But ice doesn't just sit there. It moves, flows like incredibly slow rivers, grinding over the landscape, scraping, polishing, carving valleys and fjords. Where you are, embedded in the rock beneath, you feel the ice sliding overhead, the pressure pulsing with each glacial surge. Sometimes the ice lifts you, plucks you right out of the bedrock, incorporates you into its frozen body, carries you hundreds of miles. You're in a piece of granite now, a boulder the size of a house, being carried south by the ice sheet. It's a strange journey, sometimes moving inches per day, sometimes stuck for decades. The ice around you is layered, each year's snowfall compressed into bands like tree rings, recording ancient weather patterns, volcanic eruptions that left ash layers, even cosmic dust that settles constantly from space. The Ice Age isn't constant. It pulses. Every 40,000 years or so, Earth's orbit shifts slightly, changing how sunlight hits the poles, and the ice responds, advancing, retreating, advancing again. Each pulse leaves its mark. Terminal moraines where the ice stopped, scratches on bedrock showing flow direction, and boulders like yours, erratics they'll be called, rocks transported far from their source. When the ice finally retreats, it doesn't go quietly. Massive floods pulse across the landscape as ice dams break. Meltwater lakes the size of seas drain in days, carving canyons, moving boulders, rewriting geography. Your granite boulder is dropped in a field in Iowa, hundreds of miles from where it started. A lonely monument to the ice's reach, recording in its position the maximum extent of the glacier. But you're also recording something else in that granite. The minerals are slightly damaged. Radiation from cosmic rays while the rock was exposed at the surface, creating specific isotopes that accumulate at a known rate. Scientists will one day measure these isotopes, calculating exactly how long your boulder has been sitting in that field when the ice left it there, adding another timestamp to Earth's memory. The Ice Age continues its cycles, advancing and retreating, and each time it leaves more memories. Layers of glacial till, unsorted sediment dropped by melting ice, varved clays in glacial lakes, annual layers of light and dark sediment, like pages in a book, each one recording a year of the Ice Age, summer and winter preserved in alternating bands. You weather out of the granite eventually, becoming part of the soil, rich, fertile soil that formed from the glacial deposits, ground-up rocks from thousands of miles away, mixed and distributed by ice. This soil will one day feed prairies and farms, but for now it's recording the transition, the warming that ends the Ice Age, the return of forests, The arrival of humans who will learn to read all these stories in stone. In the soil, you're taken up by a tree, incorporated into its wood, then released when it dies and decays. Washed into a stream, carried to a river, deposited in a delta. You're still recording, still remembering, now preserving the chemistry of the modern world, the temperature of recent centuries, the pollutants of industry, the isotopes from nuclear tests, all of it recorded in the sediments accumulating right now. And here's something beautiful. You're not unique. Every iron atom in every rock has a story like yours. Billions of years of journeys, transformations, recordings. The mountains around you, their libraries. The pebbles in rivers, their history books. Even the sand between your toes, each grain remembers. Some rocks are still recording right now. Stalactites adding their daily drip. Crystals growing atom by atom in deep caves. Sediments settling on ocean floors. Each one preserving this exact moment. The chemistry of today's rain. The temperature of today's oceans. The cosmic rays hitting Earth right now. In millions of years, these will be ancient memories, read by beings we can't imagine, learning about our time from the rocks we're creating today. The cycles continue, always. Rocks form, weather, reform. Each transformation recording conditions, preserved moments. The iron atom that is you has been through so many cycles: stellar formation, planetary accretion, differentiation, volcanism, sedimentation, metamorphism, weathering, and each cycle adds layers to your memory, like a story written over and over, each version adding details, none ever truly erased. Think about this tomorrow. When you see a simple rock, it might contain iron that remembers the birth of the solar system, silicon that records ancient volcanoes, calcium from shells of creatures that lived before dinosaurs, oxygen that remembers when Earth's atmosphere changed. Every element, every atom, carrying memories spanning billions of years. Rocks remember through their crystals, the way atoms arrange themselves, perfect geometric patterns that only form under specific conditions. They remember through their chemistry, trace elements that reveal their history, isotopes that act as clocks. They remember through their layers, each one a page in Earth's diary. They remember through their minerals, each species stable only in certain environments. They remember through their textures, the size and shape of grains revealing how they formed. And the memory isn't just in the solid rocks, it's in the water too. Every river carries dissolved minerals that remember the rocks they came from. Every ocean holds the accumulated memory of billions of years of weathering. The salt in the sea. It remembers ancient evaporated seas, volcanic gases, the slow dissolution of continents. Even the air holds memories, noble gases that have been cycling through rocks and atmosphere since Earth began. You settle now into a quiet place, a grain of magnetite in a peaceful lake bed, recording the gentle rhythm of seasons. Spring floods bringing fresh sediment. Summer algae blooms leaving organic layers. Autumn leaves settling and decaying. Winter ice pressing down. Then spring again, and again, and again. It's the slowest music. Each year, a single note in a song that plays for millennia. The magnetic field is something special you record as magnetite. You align with Earth's magnetic field as you crystallize, pointing north like the world's tiniest compass. And here's the remarkable thing. Earth's magnetic field flips sometimes. North becomes south. South becomes north. It's happened hundreds of times. And every time magnetic minerals like you crystallize, you record the field direction, preserving a history of Earth's magnetic wanderings. Scientists can read these magnetic memories, tracking how continents have moved. When the magnetite in a rock points the wrong direction for where it is now, it means the rock has traveled, maybe thousands of miles, carried by tectonic plates. Your magnetic alignment is like a GPS recording from millions of years ago, showing exactly where you were on Earth when you formed. In the lake bed, you're so peaceful now, just recording, always recording. The water above is full of microscopic life, diatoms with their glass shells, each species preferring specific temperatures, specific chemistry. As they die and settle, they create layers that record ancient climates with incredible precision. You're mixed with them, iron among silicon, different atoms with different memories, but all telling the same story of patient time. Sometimes pollen settles with you, each grain distinctive to its species. Pine pollen with its little air sacs, oak with its characteristic shape. They record what grew around the lake, how forests changed, when new species arrived, when others disappeared. It's all there in the sediment, a botanical history written grain by grain. The lake itself is temporary. You know this. Everything is temporary in geology, even things that last millions of years. Lakes fill with sediment, or drain when rivers cut new channels, or dry up when climate changes. Your lake is filling, getting shallower each century. Marsh plants growing in from the edges. Eventually, it'll be a meadow, then a forest, and your sediments will be soil, deep, rich soil full of memories. But for now, just rest, just record. The moonlight on the water creates tiny temperature differences that affect how minerals precipitate. Recording the lunar cycles, the wind brings dust from distant deserts, each grain telling stories of faraway places. Even the cosmic rays that constantly rain down, altering atoms, creating isotopes. They're recording too, marking time in ways we're only beginning to understand. You know what's extraordinary? Right now, at this very moment, rocks all over Earth are recording today. This exact day. Stalagmites in 10,000 caves adding an invisibly thin layer. Crystals in hot springs growing by one atomic layer. Coral reefs incorporating the chemistry of modern oceans into their skeletons. Sediments settling in every lake, every ocean. Preserving pollen from this year's flowers. Shells from this season's plankton. In millions of years, long after we're gone, these rocks will still remember today. The temperature, the atmospheric composition, even the radioactive isotopes from our nuclear age. It'll all be there, locked in stone, waiting to be read by someone, something that knows how to listen to rocks. And you, little iron atom, you'll continue your journey, weathering out of that lake bed someday, carried to new places, incorporated into new minerals, recording new memories. You've been doing this for 4.5 billion years, and you'll continue for billions more until the sun expands and Earth returns to dust, giving you back to space to begin again in some distant stellar nursery. The cycles within cycles are what make it all so beautiful. Daily cycles of temperature affecting crystal growth, annual cycles of seasons leaving layers, 1,000-year cycles of climate, million-year cycles of mountain building and erosion, 100-million-year cycles of supercontinents forming and breaking apart, billion-year cycles of atmospheric evolution, all of them recorded, all of them remembered, in every rock, every grain, every atom. Some memories are obvious, like fossils, the shapes of ancient life preserved in stone. But even without fossils, rocks remember life. Limestone that only forms from the shells of organisms. Iron formations that record when bacteria learned to make oxygen. Coal and oil preserving the carbon of ancient forests and plankton. Life and rocks have been writing Earth's story together, each affecting the other, each recording the other. The patience of it all is what's so peaceful. Rocks don't hurry. They can't. They operate on a time scale that makes our lives look like sparks, brief flashes of consciousness against the slow, steady accumulation of geological time. But that's what makes their memory so perfect. They're too slow to forget, too patient to overlook anything. They just record and keep and wait. As you rest in your lake bed, feeling the gentle weight of new sediment settling above you, you're aware of all your fellow atoms around you, each one with its own incredible journey. That silicon atom next to you might have been in a dinosaur bone. That oxygen might have been breathed by the first fish. That carbon might have been in stromatolites, the earliest visible life. You're all here together now, recording this quiet moment, this peaceful place, adding one more page to Earth's infinite book. The stars wheel overhead, the same stars that gave birth to you. Their light takes years to reach Earth, so you're being bathed in memories. Light that left those stars when you were in a different place, a different mineral, recording different moments. Even starlight is a kind of memory, carrying information across space and time, just like you carry information through Earth's deep history. Tomorrow, when the sun rises, warming the lake, stirring the water, a few atoms at the surface will evaporate, beginning their journey through the atmosphere. Some will fall as rain, weathering rocks, carrying their memories in solution. Others will be incorporated into plants, becoming part of life for a while, before returning to the geological cycle, always moving, always changing, always remembering. And so here you are, one iron atom among countless billions, resting in the quiet darkness of sediment. Your story far from over but pausing, just for now, just for this peaceful moment that might last 1,000 years or 1,000,000. It doesn't matter. Time has become something different for you, not a race or a countdown, but a gentle accumulation, like snow falling, like crystals growing, like memories settling into stone. You've traveled from the heart of a dying star to this quiet lake bed. You've been molten, crystallized, weathered, dissolved, reformed over and over. And every transformation has been a kind of remembering, a way of preserving the conditions of that exact moment. Temperature, pressure, chemistry, all of it locked into the arrangement of atoms, the structure of minerals, the layers of rock. The sediment around you is getting heavier, pressing down, beginning the slow process of turning mud into stone. Lithification, they call it. Such a gentle word for such a patient process. The water being squeezed out, minerals beginning to cement grains together. You're becoming part of a new rock, a mudstone that will preserve this lake, this moment, this quiet evening under ancient stars. And you're so tired now, so ready to rest, to just be still and record the weight of time. Your journey has shown how every rock is a library, every crystal a book, every grain a word in Earth's endless story. The mountains aren't just standing there. They're remembering their birth in collision, their rise from the sea, their slow surrender to erosion. The pebbles in streams aren't just tumbling. They're carrying memories of the peaks they came from, the storms that broke them free, the miles they've traveled. And if you're still awake, still drifting with me through these layers of time, that's perfectly beautiful. Sometimes the mind needs to wander through deep time like this, to feel the patience of rocks, the persistence of atoms. Maybe you'd like to continue this journey. There's another story waiting, another peaceful exploration through the cosmos. You don't need to do anything. Just let the next tale begin. Let it carry you even deeper into rest, further into the quiet spaces between thoughts, between heartbeats, between the ancient rhythms of Earth. The next story is already there, ready when you are. Maybe it's about the dreams of planets, or the memory of water, or the songs that crystals sing in frequencies too low for us to hear. Just let it play. No need to move. No need to decide. The universe has infinite stories to tell, infinite ways to cradle you into sleep. And if you drift off before it begins, that's perfect too. The rocks will keep their memories whether you're listening or not. They've been keeping them for billions of years. But maybe you're finding such peace in being this iron atom, in feeling the weight of sediment, the patience of geological time, that you want to stay here just a little longer. That's okay too. We can rest here together, in this space between waking and sleeping, between one breath and the next, between the formation of one mineral and another. There's no rush. There never is in geology. Everything happens when it's ready, when conditions are right, when the patient universe decides it's time. Thank you. Thank you for taking this journey with me, for becoming an iron atom, for feeling the memory of rocks in your bones, which themselves are made of minerals, calcium and phosphate, recording your own story. You've traveled billions of years tonight, from stellar furnaces to quiet lake beds, and through it all, you've been witnessing, recording, remembering, just like real atoms do every moment of every day. I hope you feel it now, how you're connected to everything. The iron in your blood came from stars, traveled these same kinds of journeys. The calcium in your bones was once in ancient seas, in the shells of creatures from deep time. You're made of atoms that remember, minerals that have stories, elements that have been cycling through Earth since the beginning. You're not separate from this planetary memory. You're part of it, adding your own layer to the story. When you wake tomorrow, if you remember anything from tonight, let it be this. Every rock you see is a book. Every grain of sand is a memory. Every crystal grew under specific conditions that can never be exactly repeated. They're all unique, all special, all holding irreplaceable records of Earth's long story. And you're part of that story, made of the same patient atoms, the same remembering minerals, the same cosmic dust that's been recording everything since time began. So rest now. Rest like rocks rest, with infinite patience, infinite peace. Let your breathing slow to the rhythm of sediment settling. Let your heartbeat match the pulse of crystal growth. Let your thoughts drift like atoms in solution, finding their perfect place, their stable arrangement, their crystalline peace. The rocks will continue remembering while you sleep. Stalactites will add their nightly atoms. Crystals will grow their patient layers. Sediments will settle in the darkness of ocean depths. And somewhere, in some quiet cave or deep lake bed, an iron atom just like the one you've been tonight is recording this exact moment, preserving it forever in the eternal memory of stone. Good night, my friend, my fellow collection of ancient atoms. Sleep deep, sleep well, knowing you're held by the same forces that hold mountains, cradled by the same patience that grows crystals, remembered by the same stones that have been keeping Earth's memories since the world began. Sweet dreams, let them be full of starlight and stone, of crystals growing in perfect silence, of time moving like honey through the patient earth. And know that tomorrow, and for billions of years to come, the rocks will still remember, will still be recording, will still be keeping the story of everything, including this gentle moment when you closed your eyes and drifted into sleep. Good night, sweet dreams. Rest now in the infinite patience of geological time.